Hey guys, today we're going to be learning about the Euler's method, or pronounced actually Euler's method. Basically, what it's used for is to just approximate the solutions of a function when you can't really solve it by itself. So, let's say we have a graph of something like this curve. The approximate solution will be pretty close, something like that, So the function for the Euler's method would be y(n plus 1) equals y to the n plus f of x and comma y to the n times change in t. So basically, to find the next y value of the function, you need the previous value plus the value plus the value of the previous function times the change of interval. So let's do an example and use the equation dy dt equals y squared minus y to the y cubed, where when x is 0, y is 0.2, and the change in t equals 1. You have to be given all of these to start it. So what you first want to do is create a table where this is n, this is x to the n, this is y to the n, and this is the value of the function at those values. So first value, n equals 0. We know that x equals 0 and that y equals 0.2. So our function is y squared minus y to the third. So find the value, just plug in 0.2 into that, and you'd end up getting 0.032. Now, to find the second value, since you know that your change of interval is 1, your next x value would be 1. Your next y value equals what this function says, the previous y value plus the function value times change in t. But since the change of t is 1, we can just ignore that. So we want the previous y value, which is 0.2, plus the previous function value, which is 0.032, and you would add those up to get 0.232. And you plug that into the equation to get the function value, and you'd end up getting 0.0413. So now the third value, you know the change in interval is 1, so you know the next x value would be 2. The next value is the previous y value plus the function value, which would be 0.2733, and the function value is just you plug that y value into that function and you get 0.0543. Alright, you just can keep on doing that. We'll go up to the fifth value. So we know the third value, x value would be 3. Y value is the previous value plus the previous function value, which equals 0.3276, and then function value is 0.0722. And so keep continuing. And let's use the same example, except when change in t is actually 0.5. So I guess now you could start all over again. We have our table. We start at n equals 0. X to the n would be 0. That's their initial values. It's going to be the same exact thing. However, now the next x value is 0.5 because our change in interval is a half instead of 1 now. And the y value now is the previous y value, which is 0.2, plus the previous function value, but this time you gotta multiply by a half, so instead of 0.232, it's gonna be 0.216. And you still just plug 0.216 for the function value, and you get 0.0366. And so we can continue that, and we get next x value is 1. The next y value is 0.2343, and the next y value is 0.0420. Well, that's how you do Euler's method, guys. Thanks for watching.